Cut.
What is up guys, it's your boy Pisan. So for today's video, I'm going to do a summary of chapter 3, so please listen. So the topic on chapter 3, network protocols and communication. We all know that communication is a connection between one people to another people, or can be a device to another device. So there is a communication fundamentals. A network can be as complex as device connected across the internet, or as simply as two computers directly connected to each other with a single cable. So that's how the communication fundamentals. Two and devices are connected to each other. So message and message encoding. One of the first steps to sending a message is encoding, and encoding is the process of converting information into another acceptable form for transmission. Decoding reverse this process in order to interpret the information. So that's how the sender will interpret, will encode the message, and the destination will decode the message that he or she or the end devices get on the source or the sender. So that is conclude on chapter 3. And also it has a message formatting and encapsulation. When a message is sent from source to destination, it must be used as a specific format or structure. Message format depends on the type of message and the channel that is used to deliver the message. So we all know that, for example, we are going to have a letter. We have a body, the location, the sender. So it has a format. On the message, so that it can it can be more look like message. And also it has a message types. So also in chapter 3, it talks about the how many would receive the message of the sender. It has a broadcast, multicast. When we say broadcast, it can be all people or end devices will receive the message of the sender. And also it includes the benefits of using a layered model. The benefits to using a layered model to describe network protocols and operation include assisting in protocol design, fostering competition, preventing technology or capability changes in one layer, and providing a common language to describe networking. And also So basically, this chapter, or the chapter 3, talks about um, how the message will be sent to the receiver, and or how the receiver will receive the message. So chapter 3 also, it includes the message segmentation. In theory, a single communication such as music, video, or email message could be sent across a network from a source to destination as one massive, uninterrupted stream of bits. So also includes in the chapter. So as I said, it also includes the encapsulation and the capsulation. So when encapsulation when sending message on a network, the encapsulation process works from top to bottom at each layer, and upper layer information is considered that data within the encapsulated protocol. For example, the TCP segment is considered the data within the IP packet. And in decapsulation, this process is reversed at the receiving host and is known as the encapsulation and encapsulation. Is the process used by a receiving device to remove one or more of the protocol headers. The data is encapsulated as it moves up the stack towards the end user application. So also the network addresses are included on the chapter 3. The network addresses, the network and data link layers are responsible for delivering the data from the source device to the destination device as shown in figure 1. Protocol at both layers contains a source and destination address, but the addresses have different purposes. So network layer, source and destination address responsible for delivering the IP packet. Data link layer, source and destination addresses. So network layer, source and destination addresses responsible for delivering the IP packet. Data link layer, source and destination addresses responsible for delivering the data link. So that's how the addresses works. The data link addresses, or the physical address, has a different role. So that are the things, and also the device on the same network, also included on the chapter 3. The role of a network layer addresses. A network layer addresses, or IP addresses, indicates the original source and final destination. And an IP address contains two parts. Network portion, the leftmost part of the addresses, that indicates which network that the IP addresses is a member. And also the host portion, the remaining part of the address that identifies a specific device on the network. And also the subnet mask is used to identify the network portion of an address from the host portion. The subnet mask is discussed in later chapters. So let's go. And also the subnet mask is when we are configuring the 255.255.25, that thing is the subnet mask. So in chapter 3 also, it includes the device on a remote network. But what are the roles of the network layer addresses and the data link layer addresses? When a device is communicating with a device on a remote network, in this example, we have a client computer PC1. So, communicating with the server named web server on different IP network. Yeah, it has a, for example, source IP address. The IP addresses of the sending device, the client computer PC1, is the 192.168.1.110. So the destination IP addresses is the IP address that we will make to go for the message to go to the another destination. We can have a server 172.16.1.99. So the source IP address will go to the destination IP address. Basically, basically it talks about how the message sent and also how the receiver will receive the message. So that concludes the chapter 3. So thank you for listening, and God bless.